everybody. Today we're going to be doing another LeetCode problem. This one's called Container with Most Water. It's a LeetCode medium, and we'll be solving it in C++. So we're given an integer array height of length n, where there are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So basically, this is a very wordy explanation of this problem, but put simply, I think this picture really helps me understand it way better than the above explanation. So we're going to be given an array of integers, and we basically want to find the maximum area where water can be stored between two of the integer values in the array. So as you can see, the maximum area for this problem is going to be between this element here at I equals 1 and this element here at I equals, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8 at I equals 8. So, and then it's basically, you use the minimum value of those two tallest or two greatest values to form that area, because we're imagining the area is being filled by water. So we can see there the output is going to be 49 because the area is going to be just the minimum value of those two greatest walls times the distance between the indices, which is 7. So 7 times 7 is 49. So that's the output there for that input output case. Now the next example, you just have two elements, and obviously the output there is going to be 1 because there's only one possibility here, one possible answer, and the area is just 1 times the distance between the indices. So you get 1. And notice that we cannot have negative element values. So that's handy. And yeah, so let's get into the algorithm here. So the solution for this problem, the optimal solution is going to be a two-pointer solution. So use 2 pointers, and that's going to give us big O of n time, as well as big O of n space, or big O of 1 space, because we're not going to be using any data structures that at all, or any that scale with the height. So for our algorithm here, the first thing we want to do is initialize our left and right pointers. So the left pointer will just start at the beginning of the array, and the right pointer, we can initialize that one to start at the end of the array. So the final element, which would be the size of the array minus 1 to get that 0 indexed final element. And then we also need to keep track of the max area that we're currently at, or the overall max area rather. So I'll just declare a variable called max area, and that can just be 0 at first, because we're going to check the array has to have at least 2 elements. So as soon as we check those first 2 elements, this will increase to a greater number. And then we just want to loop while the left pointer is less than the right pointer. And the first thing we do in this linear while loop is compute the current area we're at. So to compute the current area, I'll just call that int area, it's going to be the minimum value. Remember, we want the minimum value of these, of the two elements we're looking at with those pointers. So the minimum value of the height of the left plus the minimum, or not plus, but the minimum between the elements at the left pointer and the right pointer times the distance between those indices. So that will just be right minus left. And I'll throw in some more parentheses here for clarity and to make sure the code executes properly, or as we intend. So the next thing we want to do, we have this current area. Now, is this area greater than the max area? If it is, we want to set it to the new max area. So we can just take advantage of the max function that's built into C++ to do this. So max area is going to be equal to the maximum of the area and then the current max area. Now the next step is going to be to update our pointers. Now how do we want to do that? Well, basically we're just going to be comparing the values at the two pointers, and if the value of the left pointer, so if the value of the left pointer is less than the value at the right pointer, we can just go ahead and increment that left pointer. And basically what that's doing is, as you can imagine, say, we start at, for this example, say we start at 1 and 7. Well, 1 is way less than 7. So in order to try and find a container that will hold more water, we're going to move the smaller value here to try and find a bigger wall for this pointer. So that's basically what we're doing. So then 1 would be 8, and then suddenly you have the bigger wall there. That also happens to be the answer for that example. So the other condition is if we're going to have the mirrored situation on the other side for the other pointer. Sorry, still for both pointers, but the mirrored situation where the right value is greater than the left value. In that case, we'll just decrement the right pointer. And finally, if the last possible case is when they're equal, we can just decrement both, or iterate both pointers. So that would be decrementing the right and then incrementing the left. That's pretty much it for the algorithm. And we just return our max area at the end of this. So let's go ahead and run this code. And it passed the initial test cases. So let's submit to see our percentages. And beats 78% for runtime and 92% for memory. So again, we're using O of n time complexity here because this is just a simple linear traversal with using two pointers. So if you were to just keep getting this case over and over again, you would iterate n times at the most, at the worst. So, and then for space complexity, it's constant because we're not using any additional data structures here. Just some pointers, and that's going to be constant for any size array we get for the problem. So hopefully this helps you understand the problem better. If it does, please leave a like and subscribe. Helps me out a lot. So thanks, and I'll see you guys in the next one. Peace.